this section, we went over how to optimize your application for performance in Node.js. We used a few modules that we had not encountered before. The first one was DNS. DNS was the module that we used in order to try to make an attempt to resolve the host names that the users were giving us prior to adding those checks to all the other checks that our workers have to perform in the background. Making these kind of adjustments to your application upstream of where any issue exists can really help save your system resources later on. Another module that we used was performance hooks. This is the module most clearly dedicated to performance within Node. It globally is called the Performance Timing API or performance hooks. It is still, as you see, in experimental mode. It really is not a stable module, but since it's something you're only using to diagnose issues, in my opinion, it's fine to use because it's not something that you would necessarily deploy to production. There wouldn't necessarily be any reason to deploy it to production, especially if you can recreate any performance issues locally. If you are going to deploy your performance timing to production so that you can get some readouts from your production server, just keep in mind that it's not the most stable API yet. In future versions of Node it will be, but for now they are still open to the idea of making changes to it, and it really hasn't become a hardened API yet. That being said, it gives us extremely powerful tools for measuring code execution without having to jerry-rig anything ourselves. The next section that we used was the cluster module. Cluster allowed us to spawn our server so that it could use a bunch of different cores at the same time. In our example, we're running on a 4-core system, and so we were able to start up 4 different servers that were all sharing a certain port, and we're all listening for requests and balancing the load between them. Cluster is a stable module. It is something that you can use in production, but it is extremely complicated, and so just make sure that if you're going to use cluster, you have a good reason to do it, and just be aware that when you move a Node application from taking up one of the cores of a machine to taking up all of the cores, the results on that machine may vary. It is much more likely that you'll end up consuming the resources that other tasks on that machine may need. Lastly, we used child processes in order to drop down to the command line and issue that ls that let us read from a directory. Child processes are extremely powerful as it's a way that allows you to branch out from Node to any other application or any other process that might be more performant in a certain area or might be custom built to handle a process that Node can't handle. Using child processes is a pretty common thing to do in Node, and it is a stable module, so you should feel free to branch out any processes that you need to connect to. So at this point in the course, you have created an API, you've created a front end for that API, you've created a command line tool, you've added tests and learned how to do debugging, then you've done performance optimization and performance timing on that application. So at this point, the majority of the lectures are finished. In the final section of this course coming up next, the only things that we're going to talk about are the various modules from these docs that we just didn't happen to hit over the course of this lecture series. I wanted to make sure that this course was complete and hit all of the sections in the Node.js docs, and so in the next section, we are going to do some examples with some of the modules that we haven't talked about yet, and at least give an overview of some of the modules that we won't be dealing with at all. For example, the deprecated API section, etc. Without further ado, let's move on to the final section of this course.